In this video, we're going to be looking at algebraic identities. Expressions are said to be identically equal if they're the same for all possible values. And to show it, we use this symbol, which is like an equal sign with an extra line. So for example, 3x is identically equal to x plus 2x. And this is true for all possible values of x. If expressions are identically equal, then the coefficients of each of the terms in them must be equal. That is, the coefficients of x, x squared, x cubed, etc. in both should be the same. The value of the constant term should also be the same. Now the word coefficient is just a fancy word to say how many of each variable we have. For example, the coefficient of x squared in the expression 5x cubed minus 6x squared plus 5 is -6. Some examples of algebraic identities. In each of the following cases, we've got to find what a and b are. So the trick is going to be, expand out the brackets first of all. So here, 3 lots of 2x plus 5 is 6x plus 15. And then compare the 6x plus 15 with ax plus b. And if you can see that we've got 6x on the left and ax on the right, so a must equal 6. And then the constant term, we've got 15 on the left, and we've got a b on the right, so b must equal 15. Easy as that. Question B. First of all, expand out the bracket. Multiply every term in the first bracket by every term in the second bracket, and simplify. Now we're going to say that what we just simplified there is equal to x squared plus ax plus b, and we're going to compare them. Now we've got the same number of x squareds on both sides because we've got one of them. And we should have the same number of x's on both sides. So if you look here, we've got 7x on the left-hand side and we've got ax on the right-hand side. That tells me that a must equal 7. And similarly, the constant term, I've got 12 on the left-hand side, and on the right-hand side, I've got a b. So b must equal 12. Okay, and our next question. Expand out the brackets, but if you look here, we can be a bit clever because we just do the first bit of it because I want to find a must be 6 just by multiplying that first term. And I want to find what b is. Well, 1 times b has to equal -4. So b must be -4. So we could actually do that one a little bit quicker. Slightly more complicated, but the same process. We need to expand out our brackets and simplify first. So expanding this one through, collecting all our terms together, and it tells me we've got 29x plus 9 on the right-hand side, on the left-hand side. On the right-hand side, we've got ax plus b, and when we compare them, 29x is the same as ax, so a is 29, and 9 is the same as b, so b is 9. Second example, expand out the brackets, first of all, same as before. So remember, multiply every term in the first bracket by every term in the second bracket and simplify. And then write out what we've got. So we've got x squared plus 7x plus 12 plus ax plus b, and that equals x squared plus 12x plus 20. Now we can see we've got the same number of x squareds on both sides, so we can ignore that. Here I've got a 7x and an ax, a plus ax. On the right hand side I've got a 12x. They must be the same. So 7x plus ax must equal 12x. Or 7 plus a must equal 12, and you can deduce that a must equal 5. Similarly, we've got a 12 plus b on the left hand side and a plus 20 on the right hand side. So therefore b, by subtracting 12 from both sides, b must equal 8.